Okay, we retain another integral. This one's from the MIT Integration Bee 2006, problem 40. We've got the integral of sine x minus cosine x over square root sine 2x dx. Okay, to get started with this, the thing I noticed here is this has been coming up a lot lately where we've got sine of 2x inside a square root and then we've got something with sines and cosines. This is a good case where we can do a u substitution, but it just takes a little manipulation first. To start with, what I'm going to do, I'm going to factor out a minus sign and then switch the sign here. And then I'm going to kind of do my u substitution in reverse, where what I'm going to do is I'm going to say I want everything up here to be my du. So we'll start with that. We'll write it as du equals cos x minus sine x dx. And then from here, we just need to find our u. You could just integrate this, but we can pretty much see what it is because we just have sines and cosines. So if we look, we can write u as sine x plus cosine x. Just notice going the other way, the derivative of sine is cosine, the derivative of cosine is minus sine. But now the trouble from here is we don't have this u anywhere, right? What we're going to do is we're going to take this sine 2x and we're going to rewrite that and put it into this form. And so I'll work from this, and what I can do is first let's square this. If you square this, if you square it, what's going to happen is we're going to have sine squared plus cosine squared. That's going to give me a 1. Then for the middle terms, multiplying it out, you're going to get plus 2 sine x cos x. But this right here is just the double angle formula for sine, so I can rewrite this as sine of 2x. And then solving for sine 2x, we get sine of 2x is going to be equal to, subtracting off of 1, we get u squared minus 1. So now we have everything we need to just go ahead and substitute. We've got our minus out front. Everything up here is going to be du. And then inside the square root, we've got this value, so we're going to have square root u squared minus 1. But now for this is a really common integral, so I'm just going to use a formula on this. Let's take a look at that really quick. Okay, now we have our formula over here that we want to use for this, expressing this in terms of the natural log. You may recognize this. This is also the same thing as cosh inverse. So we're going to, MIT is the solution in terms of natural log, so I'll do it that way, but you could also just use it like this. So going ahead with this, we have our minus out front, natural log, and everything here is just going to be u plus square root u squared minus 1. And then from here, all we need to do is back substitute in order to finish it off. But now we already have this square root u squared minus 1 value. Well, we have the u squared minus 1 value right there. We just need to put this inside of a square root like this. And so for my final solution to this, we just get minus natural log sine x plus cosine x plus square root sine 2x, add a plus c, and that's it. Okay, there you have it. Good problem from MIT 2006. Thanks everyone for watching. Have a good day.